best of my ability. But today I wanted to talk about creating custom views, mainly in iOS. Some of this stuff will apply to OS X, but there's kind of some different things with views that you have to worry about there. So just dive right in here. How do we build amazing UI, right? So I don't know how long you guys have been at this, right? I'm sure you've customized UI views by their properties, right? Set background colors, done all that stuff. You've probably customized UI views by modifying their layers. So you guys ever needed like rounded corners on something, right? You set layer dot corner radius to something. And usually like you can get away with doing those two things and compositing a bunch of views together, right? So I think like for the first 3 years of my career, I didn't have to write any custom iOS views. At least I did custom drawing. Like most things I could put in, they were, just a matter of stacking a bunch of images on top of things or customizing the view. So, what if that's not enough? Like, what if you can't get what you want via compositing or just by modifying the view? So for instance, like, what if you got a data-backed view? So every time someone launches the app, they're going to see something personal to them. And what if you need to animate the way that data gets shown, right? These are two big things that you may use custom drawing for. So you see, like this app has a nice little animations. So we'll kind of go through how to do a very basic version of the top graph there. I'm going to start out just showing you how to draw it statically, and then show you a couple things with Interface Builder that you can do with views, and then we'll move into like how to animate that. So you get more control over our UI by drawing with Core Graphics, right? So Core Graphics, this awesome framework. You can draw sweet things like that. Unfortunately, I didn't put that together for my demo, but anyway. What have I done recently that caused me to kind of go down this road? Here's a really simple one, just a loading indicator in an app. So that's a custom layer animation that's doing that. This next one's kind of a graph that can switch between modes and do stuff. So this is another custom view. And then this one on the far right is kind of a behemoth one that we're working on. Oh, it's got audio too. Anyway, so that's me talking at the office this afternoon. So lots of custom stuff here. All of these are showing unique data to whatever the user's viewing at that time. Here it's open rate, click rate, shares. Over here it's kind of your walking activity, and there's a bunch of stuff that flies around on the orbits and stuff like that. So you can get pretty detailed with this stuff if you want to. So let's back up a little bit, and talk about kind of the roles of these two pieces. We're going to talk about UI views and CA layers. So a UI view, its role is really to render content. Kind of the big differentiating factor between it and a layer is that a UI view can handle interactions. So, tap gesture recognizers, all that stuff you can install in the UI view. A UI view is also responsible for managing its subviews. Probably stuff you guys have all done before. Like I said, we can customize UI views through its properties. So just a few here, right? We got alpha. We can change the background color. You can set a pattern, if you wanted to. We can transform the view, so we can skew it. We can move it around the screen, that type of stuff. Where do CA layers come into the mix? So how many of you guys have messed with CA layers before? Yeah? All right, sweet. I may not be telling you anything new here. But so in iOS, in UIKit, every UI view is backed by a CA layer by default, which is nice. On OS X, you're going to have to manually turn this on. I believe there's a switch in Interface Builder where you can do it on like the root view and it'll cascade down the view hierarchy. But there's also a property on each view. You can say set once layer to yes to turn that on. CA layers effectively delegate the drawing to the UI view's DrawRect method. So whenever you see that DrawRect method, it's really the layer underneath asking your view to draw its content into a context. So just something to be aware of there. So we can do a lot with CA layers as well, and these will affect the views that we draw. So we can do things like shadows, right? We can set the opacity and the path and the radius and all that stuff. Do rounded corners. This is probably the first thing I did when I modified a CA layer. So you can set the corner radius on a layer. You can set the border width if you want to have a border around your view. And so what if we need something more complicated, right? Like what if we've got these like crazy layer backed views? All right, so we'll talk about a few core graphics techniques here. There's a ton of stuff that you can do with core graphics. Paths are probably a good place to start, and it's where I'm going to be focusing the demo on. But there's a ton of other stuff that you can do. All of those views that you saw before, for the most part, were drawn using paths. So the loading indicator was a path. That other graph is a path with like a text view in the middle. So there's a lot of old, there's a CG path, which is kind of an old way of doing things. If you're writing code from scratch, I'd recommend using UI Bezier path. A little bit newer API, a little bit nicer, but you're basically drawing down at the level of individual lines on the screen, right? So I think one of the first programming languages I ever saw was it that Turtle program where you can say like, walk 20, like turn 90 degrees, like walk whatever, and it like draws something, right? But that's super old school. But this is essentially that on iOS. You can get pretty detailed. There's a lot of nice convenience methods for adding curves and quad curves. So if you want like smooth graphs, we're not going to do that today, but it does have ways to do that. You can also close these paths, so you can make shapes out of them as well. So you may like draw a path and then say like close path, and that'll make that the interior of that something that you can fill in with a color if you want to. So yeah, you can do shapes with Bezier path. It's got a lot of nice convenience methods here too. So if we want to draw an oval, we can do that pretty easily. I use this the arc one quite a bit. So if you want to draw like a donut chart or something, the arc's great for that. So we've got kind of two different ways to draw shapes that we'll talk about. One's to use a CA shape layer. So this would be a layer that you either set your view to be backed by, or you just install it in your layer hierarchy for your view. So that's one way to do it. You can also just draw, using core graphics code in your DrawRect. So I'm sure you guys have seen every time you subclass a UI view, it's got that big warning, right? Like, do not do anything with DrawRect. Like, it's a really bad idea. We'll talk about some of the performance considerations there. But it's not too bad of a process. Basically, you construct your path using those Bezier path methods I showed before, and you set the properties on it. So you can set the color of the line, you can set the fill, so like what the color will be inside of that path. You can set the stroke width, stroke type. There's tons of stuff you can set here. You can do a dash pattern. You do a lot of stuff there. And then at the end, you actually manually have to tell it to stroke the path or fill the path. So we'll kind of walk through what that looks like. You can also do gradients with core graphics. Unfortunately, I've had to do a few of these. They're not as easy as they seem like they would be. Axial or linear gradients and radiant gradients are pretty much all you have to run with. But they cover a lot of the cases. Again, kind of two different ways here. You can either use the CA gradient layer and install that in your layer hierarchy, or you can manually draw this in your DrawRect using the CG context draw linear gradient method. You can also draw text, right? So use CA text layer, or if you're writing a newish app, I would recommend core text. It's a little bit of a beast to deal with, but it's ridiculously customizable, and it works really well once you start, adding new languages to your stuff. So it handles glyphs and all of that really well. What else can we do? Images. You can draw images using core graphics, but I would highly recommend against it. Use a UI image view whenever you can. It's got a lot of optimizations that'll save you a lot of time. So use UI image view there. If you find yourself drawing with core graphics an image, you probably want to rethink what you're doing. Maybe you want to restructure your view hierarchy so that's just an image view. One other cool thing, and this is just kind of an aside, but with core graphics we use it a lot for sharing screenshots out of apps or drawing them differently. Say if you want to share something in a PDF format and you want to kind of relay out your data for that. you can draw them into bitmaps. You could also draw them into PDFs. Here's how you would draw it into a bitmap. So you start this image context, and then you can render your different layers in there if you want to. And then at the end, you get a UI image out, which you could store to disk or share or do whatever you want to with. Also, a lot of other stuff you can do with core graphics. You can do patterns, which are fun. So you can have a little image that you want to repeat, and you can set that as a pattern and have it repeat all the way across your view. You can also do a lot of stuff with PDFs. So if you've got a PDF vector image that you want to draw, this handles it pretty well. And in one of our apps, we had to do a lot of custom drawing of PDF pages because the stock ViewController for that didn't work very well. So you can do that. And there's a ton of other stuff in there, so I encourage you to go kind of dig around in core graphics and see what's out there. Lots of good stuff. Who doesn't love Charlie excited? All right, so let's do a little bit of a demo. So the first thing I wanted to show you guys was how to draw a non-animated graph. So this is going to be, make sure I'm on the right thing here. So this is going to be just a simple line graph. So I just made a new project here. I was going to live code, but I decided maybe it's better if I just have a repo that I can switch to different commits to. So if you guys have questions on the code as I go through it, let me know. We've got a really simple storyboard here. So get a main.storyboard with one view in it. So whenever you install a custom view, you're going to have a custom view subclass. You'll want to come over here, drag out a UI view, just a blank one, right, onto your canvas, and then make sure that you're over here in the inspector and actually set the class of that view to be your custom class. You guys have probably done this with a bunch of other stuff, but that's kind of all the magic that's happening here. I've got an outlet to this view, my ViewController. So a really simple ViewController here. All it does is it sets the graph view's data source to be the ViewController. It creates this internal values array, which is what we're going to map. So these are all Y values that we're going to map just linearly across the x-axis. And then it's going to call setNeedsDisplay on that graph view. You want to be careful with how often you call setNeedsDisplay, because that's going to tell your view to completely redraw itself, and that's often expensive. So be careful with that. But here, this is kind of quick and dirty. We're just going to go ahead and call it. And here's our one delegate method from the graph view data source, just this values to graph. It's just going to pass back the values array that we set up here in view.load. Everybody good on that so far? Let's take a look at our graph view. Really simple protocol here, just a way to ask for values to graph and a way to set the data source. So here's kind of the meat of what we're talking about today. So let's walk through a custom DrawRect implementation here. In the beginning, this view is going to ask, so DrawRect's going to get called as soon as that setNeedsDisplay gets kicked off to render the view's content to the screen. DrawRect here is using its delegate, its data source, to grab those values to graph. So that's going to give us back that array of values that we set up in our ViewController. Then we're going to create a UI Bezier path. Pretty easy. I called it graph path here. Few variables to help us along the way here. I've got a x step value, so I want to have these displayed, at equal points and filling up the entire graph. So this kind of tells me how far I need to move along x for each additional point I want to add to that line. Got a max value to graph, so things scale right, on the y-axis. So here I'm just using a simple value for key path to get the max number out of that array, so I know what the top is, and then I set up this y scale factor, which basically I use to scale all the values that I get so that they fit on the screen properly. The maximum one is going to be at the very top of the screen. And here I just grab the height so that it's a little bit easier to look at. So we've got our Bezier path that we set up here, and now we're going to start adding things to it. So I've got this array, and I'm going to loop through it using kind of an old school methodology here, but it was a little bit easier to read. So I'm just going to go through and grab every value in that array, and I'm going to graph it. Here I set up the current value, so I'm just grabbing that from the array there. So that's going to be an NS number. Then I figure out the X and Y position of that point on the graph. So this data point, I want it to live at I times the X step. So the first one's going to live at 0, and then each one after that's going to live at a place, so that it spreads out the entire X-axis. And then the Y position, kind of weird math here. You're going to find once you get into this that your math skills will really be put to the test. Like if you don't remember like how to do trigonometry or something like that, you're going to be on the internet constantly trying to figure this stuff out. This one's pretty simple, just getting the Y position, but we have to remember that on iOS the Y coordinate's flipped, right? So we're subtracting, we're doing height minus the current value times the scale factor to make sure that it fits. And then we just make a CG point from that with our X and Y position. If it's the first point on the graph, we're going to tell our path to move to a particular point. So that's going to move to like the first point that we want to draw. And then for everyone after that, we're going to say add line to point. So that's going to add a straight line from where our pointer is currently at to this new point, and it's going to set the pointer there. And then at the end of that, all we have to do is stroke the graph path, and so that's going to actually draw the line on the screen. So really important not to forget this last piece. I know it seems like you've done all the work, you set up the path, but unless you tell it to draw, it's not going to do anything. All right, so let's run that really fast. I'll just bring up the array here so you can see what we're looking at. So there's the array, and here's our ugly graph, right? There you can see like 20, 7, 0, 12, 30, right? So you can see it. All of our points on the screen, resizes nicely when we rotate, does all that good stuff. So pretty basic so far. Any questions on that? Awesome. All right, so that's kind of, when you're first starting out, I usually try to draw a non-animated version of whatever I'm going to do, right? So I pick some fake data set and throw it at it and see how it looks. All right, what I really like, and I think this is starting in Xcode 5, I believe, is using your custom views in Interface Builder. So I don't know about you guys, like I'm a huge storyboard junkie, and I hate it when storyboard just looks like a bunch of white boxes with no content in them or anything, right? Like it's just not as cool to zoom out and show someone. So I feel like a storyboard you can show someone and you're like, here's my app, and they kind of get it, right? But if it's a bunch of white rectangles, people are like, okay, well, how does that work? So there's a couple things we can do to make our custom UI views, kind of work with Interface Builder. The first thing we could do is render our view in Interface Builder. This one's pretty simple. You just add this IB designable. I'll show you in Objective-C. That's kind of the Swift mode replacer. But you just add this right before your class declaration. There's also a couple methods that you can use. So for our graph, for instance, I'll show you how I use the second one here. There's a prepare for Interface Builder method that you can use to set up your view that only gets called when your view is being displayed in Interface Builder. So any code you put in there is just for that. They also include this preprocessor macro, which is kind of nice. So you can switch in your code and say, well, if I'm building for Interface Builder, do one thing. If I'm building, in an actual running app, do something different, because you may not want to show your test data there. One other cool thing we can do with Interface Builder is actually tweak how our view looks. So we can expose properties from our custom view into Interface Builder, so that in a dream world, our designer could get in there and actually modify those values, right? And say, well, the stroke path doesn't look quite right. Let me bump that down, or let me change the color of this, or the position of this, or whatever. Lots of types of variables you can expose. All your normal, plist style variables, as well as a lot of core graphic stuff. So CG point, CG size, CG rect. All these you can expose. Even UI image, which is kind of interesting. And so the way that you do this, and I'll show you in a second, you just add this kind of IB inspectable thing to your property declaration, and it actually exposes it in the UI and Interface Builder. So it's kind of cool. You can get in there and modify, like you can modify your X and Y coordinate right now. You can now get in there and modify things about your custom view. which is really cool. And the other thing to remember about this is if you make changes in Interface Builder, it's going to override your initialization code for the view. So you may have your view set up like I had to just draw a black line, but if someone goes in Interface Builder and turns that to an orange line, let's say, that's going to override whatever you have in code. So that's kind of a weird gotcha. If you're not used to this, you may say, how did that line get to be orange? Look for those in the code. All right, so I'll switch to my second demo here. So just show you guys how that stuff works. Try not to judge me for using a GUI for Git. All right, so our ViewController here is largely unchanged. The big things that happened were in our graph view. So I've added this IB designable macro here, and that's going to tell Interface Builder that this is a view that we want to render, live in Interface Builder. I also added a couple properties, just exposed a couple things about our custom view that we may want to tweak. So the line color and line width were two things that were really bothering me with that last graph. Like, they didn't look that great. So I'm exposing those here, and I'm putting this IB inspectable in front of the class type. That's going to make it show up in Interface Builder. Just to show you what I changed over here, we still got our DrawRect. I broke out getting the current path into its own method, but it's all pretty much the same code. The only big difference is here. If I'm targeting Interface Builder, I'm just going to throw it an array of values, just so I have something to look at when I'm in Interface Builder. Otherwise, I'm going to use that same delegate method as before, so when we're running the code, it's actually going to get these values live. But in Interface Builder, it's going to use this array up here. Everything else is pretty much the same here, except for that the line width is going to come in through this custom variable that we have now, and the line color is actually going to come in through our custom variable. So let's watch the magic happen. So if you switch over to Interface Builder, you'll notice it's compiling. Now it's got our graph, right? Look kind of familiar to you guys. Over here on the right, our identity inspector are these two properties that I exposed, right? So I exposed line color and line width. So I can change these on the fly here. Let's make it do cyan, why not? And I really want to bump this up, so I'm going to tweak on this until I think it looks good. So maybe 20, right? Build and run this guy. And then notice now we've got kind of our custom graph, but with these modifications on it. So anyway, a lot more interesting here when you can actually see, what your code's going to be rendering in Interface Builder. It makes it really easy to go in here and resize this and do whatever, and know kind of what it's going to look like on the back end. Any questions on that?
So I thought with to use the IB designable and have it DrawRect in Interface Builder, I thought the view had to be in a framework for it to render.
So I think in Swift it does, but this is an Objective-C project.
Well, no, I tried to. I swear the documentation. I mean, it's obviously. I'm glad that it's not the case anymore, because I just remember they used to make you have it be in the iOS 8 framework.
Yeah.
That's cool though.
I haven't had any trouble with that. I mean, this does get a little bit finicky. Like, you'll notice when I modify this to animate it, I lost all my IB designable stuff. It's kind of a pain to keep up with it, but I think it's worth it sometimes. Especially if you can do so many things in Interface Builder these days. You can almost have your designer go in and tweak it for each individual screen if they want to. But yeah, it is finicky. But.
Did you use Prepare for Interface Builder?
So I didn't use that here. Yeah. If it was a more complicated view, maybe I would have set up that array there and then pulled it in later. Since my view delegates all of its stuff, I ended up using the preprocessor macro. But yeah, that's there if you need it.
How do you use the IB designable stuff for the Swift project?
So I did when I was making the demo, and it worked fine. That said, like I felt like most people here were still using Objective-C. Am I wrong about that? Are we still mainly Objective-C? So I stuck with Objective-C for this, but it does work in Swift. It looks a little bit different, but it's pretty much the same.
I think if you use Swift, the cool thing is you can actually set default values to show up in Interface Builder, since Swift actually supports default values for properties.
Right. Yeah. Yeah, that's true. So you may not even need your prepare for Interface Builder if you're using Swift, because you could set it up that way. All right. One last thing for you guys. So that's all great. We can draw custom views, and you can imagine how complicated those can get, right? We can add a bunch of layers. We can compose them. Some of those examples I showed you had 3 or 4 layers. Actually, the big like planet-looking thing has like 10 layers to it. There's a lot going on there. But the cool thing about these is that we can actually animate them. We've got 2 different ways to animate CA layer properties. So this is down in your CA layer. We've got implicit animations, so CA layer comes with a lot of animations already built in. So you can actually animate from one background color to another if you want to, or you can animate the shadow path if you're, I don't know, increasing the z-axis of that view or something like that. All of these you kind of get for free, and they're much more performant than the custom ones you would write. So if you can get away with using any of the implicit animations, try to use those. You can also set up explicit animations, which is what I do a lot of times. So say that loading indicator, I have an explicit animation on a progress value, right? So it's got a local progress value, and I want to animate that from 0 to 1, let's say, and that fills in the circle and it repeats itself. To do this, you need to subclass your CA layer, add a dynamic property to it. So in that case, we got progress as a property and make it dynamic. So don't synthesize it like you normally do or use auto-synthesizing. You'll actually have to do the dynamic in your implementation file. We also need to return yes for needs display for key. So this method gets called in your CA layer whenever one of its values changes. And it lets your CA layer say, do I need to redraw myself or not? So if this is a value that's going to affect what your output looks like, then you need to return yes for that key path. You also need to override action for key and provide a CA basic animation for your properties key. So in my progress indicator, or my loading indicator there, for progress, I put in a CA basic animation that just repeats, right? It goes and fills it in, and it repeats every time. And I actually just, in action for key, when I set that progress, it'll just run that animation over and over and over. And then the last thing you need to do is override the display method of CA layer to actually draw your content. You use all the same core graphics stuff that we talked about before. It's just in a different class. It's not in your DrawRect. It's in your layer this time. So what happens when we animate? This gets kind of interesting. So in iOS, you've got your main view that backs your layer, but while it's animating, you actually get a new layer on that view called your presentation layer. And this exists during the animation. You can use it to grab values out. So if you're halfway through an animation and you want to start it animating to somewhere else, like based on that current point, you use your presentation layer to pull out your current value that you're at to work with that. So yeah, presentation layer keeps track of the state during the animation, and then once the animation finishes, you're back to just using your regular layer. But something that tripped me up early on was I would try to set a property on the layer, and I didn't understand why it wasn't working, and it had to do with this presentation layer. So be on the lookout for that. There's another crazy thing your designer might hand you, right? But this isn't too bad of a thing to try to tackle with core graphics. This is, say that's a couple days worth of work, but it's definitely something you can build. And if you're building apps that have a lot of custom data in it, it's really nice to kind of dress this stuff up because graphs are boring. No one likes graphs. But that's pretty cool. All right, so let's do one last demo. It's kind of the last thing I have. All right. So I changed a little bit about my graph view here. What I'm going to do is use an implicit animation on CA shape layer to actually animate the graph filling in from left to right. So this is another implicit animation you can get. If you can use implicit, go for it because it's a lot more performant. I do a couple different things here. The first thing I do is create my shape layer. So the view's already got its own layer, right? I'm going to add a new layer to it. That's a CA shape layer. So I just allocated it here. I set its frame and position so that it lines up with the view properly. And then I just add this layer, very similar to how you would add a subview, right? So self.layer, add sublayer, and I put my graph shape layer in there. Come back to this update graph animated method. I just want to show you like the current path is still the same, right? I don't have anything in here that tells it to only draw half of itself or anything like that. This thing looks like it's going to draw the whole thing, but we can use this implicit animation to actually only draw a part of it if we want to. So let's look at this update graph animated. This isn't the cleanest implementation of this, but it gets the job done for now. Since we're dealing with a shape layer, we go ahead and set some things directly on that shape layer. So shape layer is designed to host a Bezier path and display it. So we can set things on that shape layer like the stroke color and the fill color and the line width. This is the big thing to look at here and how we're going to achieve this animation. Shape layers have what's called a stroke start and a stroke end value, and they tell it how much of the stroke should currently be drawn. So the default values for stroke start are 0 and stroke end are 1. So start at the beginning and draw to the end of the path. Here we're going to set the end to 0, so we're not going to draw anything. We're going to animate that stroke end out to 1 so that the path gets drawn. So here I set the path with the current path, and here I am setting up a CA basic animation. Not a huge fan of this API, but it gets the job done. I pass in the stroke end key path here, so I'm going to make an animation that animates the stroke end. It's going to last 1.5 seconds, and I'm going to animate that from 0 to 1. And these two lines here are kind of important. So a lot of times, how we talked about having the presentation layer and your other layer, right? And how your presentation layer goes away after your animation's done. If you don't set removed on completion to no and a fill mode, your view's going to animate, and then your entire thing's just going to disappear. Because the drawing only exists in your presentation layer. So these are ways to have that pushed back onto your actual backend layer. So we set all that up, and then we just add the animation for that key path for stroke end. So I just want to show you guys this interface builder. I added a tap gesture recognizer just to the main view, so when I tap it, it hits an outlet in my ViewController. And in my ViewController here, graph was tapped, actually changed the values array to something different, and then I update the graph. And that should animate the graph in. Let's take a look at what that looks like. So there's a bug here on the first draw, but click it, comes in, it animates the new thing in nicely. So I'm just using a linear animation here. Obviously, you probably want to go to a spring animation or something a little bit nicer. But hopefully you guys can see how you can start to layer these and build them up into a pretty complicated UI. That is all I've got. You guys have any questions on any of that stuff? Anything? Yeah.
How much in like trying to do CG context on the background thread?
So that does exist. So there's a draw asynchronously method that you can put on, or flag that you can set on, I believe, on a CA layer. And that's supposed to push it to the background thread. In general, if you're using implicit animations and stuff like that, that work's going to be done on the CPU or on the GPU instead of on the CPU, which is kind of the advantage to that. If you end up doing DrawRect, you may want to draw this stuff in the background. I didn't put together slides on optimization, but But typically what happens is, right, I layer like 5 things and then I see, frame rate's not great, right? And I put it in the profiler and it's like, that's not looking too great. Typically what I do at that point is start breaking things into layers. So let's go back to an earlier slide. Sorry, I hope this addresses your point.
Oh,
But,
no, I appreciate it already.
all right, so let's take this guy right here. This graph, right? It's got a lot of stuff going on. This entire white space at the top is actually the view. So, it's got this average down here. It's got kind of these lines, this background track, shares in the front here, and then this track that fills in on top, right? So play that one more time so you can kind of see how that works. After I composed all of these together, I found, wow, drawing's not very fast, right? It's not very performant. Like, it was stuttering through that animation. So what I ended up doing was breaking this into separate layers. So some layers only need to be drawn once, right? So our background track, this kind of thing going around the outside, we don't need to redraw that every frame. So I broke that out into a background layer, and that gets called once. And then as the animation goes through, really the only thing that's getting redrawn besides the text is this one, kind of color overlay there. So I found that solves most of my performance issues, doing things like that, just being smart about when you draw things, because it is expensive and it is on the CPU, so at least a lot of it is, especially if you do it in DrawRect. You can draw in the background. For stuff like this, it doesn't really help if you're animating it, because it's got to come back to the foreground and display it anyway, right? So that's typically what I've done to solve those issues. Yeah. Anybody else have questions on this stuff? So yeah, there's some great WWDC talks out there if you want to check them out that talk about this. I think they show how to reproduce the download indicator on the App Store. So that little thing that you press and it says starting, and it like starts filling in the loading indicator on the outside. There's a little stop button, and then it flips over to like open or whatever. I think they do an example of that, which is kind of nice. So I don't know. You may be able to get away without ever doing these in any of the apps you build. For some reason, lately, we've been building a lot of apps that rely on a data set that we want to display. So we've got a lot of use out of this.
Let's say you're using a CH shape layer as a mask. Would you be able to get that to show up in your interface builder with the IB designable?
Supposedly, yes. I have to say, like, the IB designable stuff, while it looks great in theory, like, tends to break down after a certain point. Like this view right here, get the audio, but this view, like, I had it being an IB designable view, and it just, like, Xcode just gives up on it. Like, it'll try to render it in storyboard, and then it's like, nah, can't do it, and it just scraps out. So I don't know, I haven't messed with masks doing that, honestly.
Or to say even just a layer property like border width or something, will that show up?
Yeah,
Okay.
that should show up. It's really, once you get into having a view that takes a significant amount of time to render, I find it kind of doesn't do its thing. But for the most part, it works. I mean, I think if you can get it to work, it's awesome. I think if it's taking too long to render, maybe you need to break your view into multiple views, right? So each one can render separately. There's a ton of stuff you can do performance-wise. Check out Instruments for this stuff too. Instruments has a really nice kind of frames per second core graphics like analyzer that you can use to make sure you're always getting 60 frames a second. Yeah. Anybody else have questions? Cool. Well, thanks for coming out. Follow us on Twitter if you want to see some funny tweets. Thank you, Jennifer, for putting together my slide deck. It's way nicer than I would have done. You might be the first designer who's come to this.
Like,
Well, besides Brent, Renaissance man.
But yeah.
Anyway, thank you guys.